Hi guys, just a couple of examples for using the unit circle, and you'll notice that I've actually already got the answer sitting right there. So like number one, the cotangent of negative 1050 degrees is actually radical 3. The point of this is not to get the answers, because ultimately getting the answers is really kind of straightforward. You go to your unit circle, you find the angle, and you just grab whatever variable that you need, or sometimes you need a combination of variables. But I picked these ones in particular because they are not within that wonderful awesome sauce unit, or I'm sorry, integral of 0 to 2 pi or 0 to 360. They're not, some positive angle that's less than 360 or less than 2 pi. So you have to do a little bit of work to get to the angle that you want to use. So for number one, you are going to find the cotangent, but what you really want to do is if you have a negative angle that's, oops, let me fix my bottom of the screen. Okay, so you've got negative 1050. If you add 360 to that, okay, you're going to get negative 690. So it's still a negative angle, still not what you want to use. So add another 360. Remember, you're really just looking for coterminal angles, and to find coterminal angles, you either add or subtract multiples of 360. So you get negative 330 there when you add a second time, and then ultimately if you add one more round of 360, you get a positive 30 degrees. So if I want the cotangent of negative 1050, it's the same thing as the cotangent of 30 degrees. They end at the same line on the unit circle. They end at the same spoke of that wheel. And remember, cotangent is going to be, tangent is y over x, so cotangent is x over y. Okay, and so you really are just going to put your radical 3 over 2 divided by 1/2. And remember, when you are dividing by a fraction, you are really multiplying by the reciprocal. You are not cross multiplying here. You are multiplying across the top and across the bottom. So you can, if you want, multiply across the top and then across the bottom and then reduce, or you can reduce those 2's right there, which is why you get your radical 3. Okay, I'm going to try to shrink. Oops, of course. That's why. Well, all right, I'll shrink some of, well, I guess I'm going to just have to deal with that. To go to number 2, secant. Okay, this one's pretty straightforward. 9 over 4, if you enter that into your calculator, you get 2.25, so 2 1/4. So just subtract. Remember, when you're dealing with radians, take the numbers and enter them in your calculator. Don't think about the pi, okay? And ultimately, you have 1/4 left, which really means you have pi over 4 left. So the secant of 9 pi over 4 is the same thing as the secant of pi over 4. Okay? And secant goes with cosine, because remember, Santa Claus, you need an S and a C together. Cosine is your x variable, and so secant is going to be 1 over your x variable. So you get 1 over radical 2 over 2. And of course, 1 times 2 over radical 2, because I am multiplying by the reciprocal. And of course, that 1 doesn't go anywhere, and we don't really need it. You have to rationalize your denominator, right? And so when you do that, you're going to get a 2 radical 2 over a 2. And of course, these guys are going to cancel out, and that's how you get your radical 2 that's sitting up over there. I'm going to do purple next, and let's see if I can squish a little bit. Nope, again, squishing all of it. All right, so 3, we want the cosecant. And so that's going to go with sine, so we're going to do 1 over y when we get there. But ultimately, again, we're worried about the angle itself that we're looking for. So negative 21 over 4. If you add 2, it's not going to be enough. Add 2, not going to be enough. Add 2, that third time around, it gets you into a positive angle, and it's 3/4. So it's really 3 pi over 4. And so we go and we find our 3 pi over 4, which is over here. Oops, sorry, that's our spoke of the wheel. And this is going to be 1 over the y value. So it's 1 over radical 2 over 2. And I'm not actually going to do all that for you again. Just trust that you get radical 2 again. All right, I'll go clean this up and make another 3 examples for this.